I'm Good morning. I'm very pleased to have Anil Sawhney with us today. And this is our first speaker series event of the semester. So I will introduce Anil, and then, like I said, you can either use the audience link to type your questions, or you're in the classroom anyway. So you can ask the question here, so I can direct it to the Dr. Sawhney. So Anil Sawhney is the global lead for the construction and infrastructure sector at the Royal Institution of Chartered Surveyors, RICS. Anil is a construction and infrastructure sector expert, an educator, a researcher, and a ConstructionTech enthusiast. In his role at the RICS, he is involved in producing the construction and infrastructure sector's body of knowledge, standards, guidance, practice statements, education, and training. He is also an adjunct faculty at Columbia University, visiting professor at Liverpool John Moores University in the UK, and an adjunct faculty at the University of Southern California. Anil has a rich mix of academic, research, industry, and consulting experience gathered in the USA, India, Canada, the UK, and Australia. In 2020, he co-authored a book entitled Construction 4.0, Innovation Platform for the Built Environment. He is currently the co-editor of the Construction Innovation Journal. Dr. Sawhney serves as the International Editorial Board of the ICE Infrastructure Asset Management Journal and the Journal of Information Technology in Construction. So welcome, Dr. Sawhney.
Thank you very much. I've just shared my screen, so I hope everyone can see it. Once again, thank you for inviting me. It's a delight to be able to speak to your students and perhaps colleagues. My name is Anil Sawhney, and thank you so much for such a wonderful introduction. I'm going to talk to you about digital twins today. The title is Twinning Construction Projects from Design to Turnover. This is an emerging field which would be of great interest, I hope, to all of you, and will bring to life some of the things that are happening in the construction sector globally. Luckily, in my role as the global lead, I'm able to see and witness and enter into discussions with various projects and organizations, starting from all the way from Shanghai to LA. And that gives me a good perspective and learning from those projects. So I'm going to try and give you some information that hopefully you will find useful. My goal is not to bore you. I hope I'll accomplish that, and you'll find the information I share useful. So broadly, what I want to do is discuss with you or give you an overview of RICS. Many of you may not be familiar with the organization, so just want to give you a quick view of that, and then obviously talk a little bit on digital twins, especially from the construction life cycle step point of view, and then leave some time towards the end for any comments, discussion, or question and answers that we can engage in. So let me start by introducing RICS a bit. RICS is a not-for-profit professional body originally based in the UK. We were founded in 1868 and were then incorporated by a royal charter about 13 years after that. We are a professional body that's aimed at producing standards and regulation for the built environment sector. We set these standards from a public interest point of view. So we are a professional body which is not for profit, aimed at public good. We deliver support that is valued by RICS members and member firms and their employers. We help develop professional skills and knowledge and expand opportunities for our members to apply those professional skills. So roughly what we do is basically everything we do is designed to effect positive change in the built and natural environments. So that's sort of our vision mission statement as RICS. As I said, we are a global body. We have about 134,000 individual qualified and trainee professional members. Our membership is what's called a chartered membership. So it's not a simple step of paying your annual membership due and becoming a member of RICS. Members have to go through a charter process in which there is sort of an assessment, there's an interview, and you have to share your project experiences, and before you get the MRICS chartered professional status. I am a fellow of the RICS. We have members spread all over the globe, as you can see. I work out of our New York office, but I'm based outside of the Washington, DC area. And similarly, many of my colleagues are spread all over the globe, with a large number of us in the UK, in London and Birmingham offices. So we operate, as I said previously, built and natural environments. We operate in the main areas of land, property, and construction. So we're really a broad church. The term surveyor may be slightly misleading. It's a UK Commonwealth-centered term. The term surveyor actually embraces from cradle to cradle all professions, beginning with land surveying all the way up to valuations and FM kind of experts also. My focus is construction and infrastructure. We have about 40% of our membership is focused on what we call quantity surveying or cost management and project management pathways. And that's how they have become chartered as members in the RICS. So that's a very quick overview of what RICS is. Let me now just jump into the main topic of our discussion today, and I hope you will find it useful and are able to connect the dots as we go into this discussion. So let me just tell you that digital twins is something that's already happening. It's happening now. I'm sure many of you will recognize this, the SoFi Stadium, which is now an operational stadium with a digital twin. This is a pretty large development, I think, by some estimates, about $5 billion worth of real estate, lots of ancillary buildings and assets surrounding the main stadium. So as the construction of this asset was progressing, the owner, the project sponsor, decided to take all the information, the documentation, all construction product methods, materials, information, and put that into a framework which we call digital twin, and hand it over or turn it over for operations and maintenance. So many of the things that you would expect somebody running this asset be able to do can now be done using that digital twin. So that's a very clear example of how digital twins are impacting our work and our participation in this emerging area. Another example recently released, the Vancouver airport has a digital twin where, again, during design and construction phases and for existing assets, all laser scans and all that material was brought together into a twin. And this twin can be used for many things. It can be used on the air side as well as on the passenger side for getting latest and real-time information. Here you see a screenshot and an example of how it's being used by the airport authorities to run the air side of the airport. Similarly, the Hong Kong International Airport has a digital twin, and it's being used by various stakeholders to run the airport with the help of data that is available through various mechanisms during design, construction, and operation. Many of you may have already a digital twin of your home. So in my house, I have various gadgets as I'm a construction tech enthusiast. We keep putting various things. You can have cameras, you can have these lock sets that can be operated remotely, garage door openers, various appliances, and all these things. So these are basically Internet of Things or devices that can go into your house during construction or post-construction. Then you could take Matterport, which is a commonplace in real estate transactions these days, and create a model of your house. All of that can then be brought together in an interface, which is called digital twin, that connects to the physical asset, and you can run your house using or operate and maintain your house using that digital twin. I have a little interface, which is a link on the top. I don't think I'm going to go there. With live demos, sometimes things can crash, but you get the point. Earlier on, each one of those devices had its own app. So on my iPhone, I could open the lock. If I forgot to close the garage door and I was in my office, I could actually use an app to close the garage door. But now it's integrated into one dashboard, one interface. And that's where digital twins come into play. Now, slowly, this technology or this approach or this paradigm is also being used on construction. So there are various startups. You all must be familiar with a construction company, which is actually based in Edmonton, now operates in North America, called PCL Construction. They used Microsoft's IoT Azure platform to develop a sort of a system whereby they can get real-time data from project sites. They've now spun it off into a separate entity called ATM Technologies, and they brought this aspect into the construction phase also. So I will share some of this information as we move forward. Now, you get the point. The idea is to develop a system whereby you have a twin of your physical asset, and you can manage, control, make better decisions, and operate efficiently the physical asset using the digital twin. So being a classroom before going forward, I think you will pardon me if I were to use a definition to tell you what a digital twin technically is. A digital twin definition centers around this very simple idea. The idea comes from the dictionary meaning of twin. If you look up the dictionary meaning of a twin, it's something containing or consisting of two matching or corresponding parts. So what does that mean in technical terms? Really, what we are talking about, two twins. So a twin that is physical and its twin that is virtual. A virtual twin could actually be a BIM model. It could be a 2D drawing. It could be just a schematic. It could be just a photograph. It could be any other digital or virtual representation of your physical asset. So the physical asset would be a pump, maybe a column, maybe a space like the classroom that you are in, or the entire building, or the campus, or perhaps any bridge or a transportation network. So that's the physical asset, and you have its twin, which is the digital or the virtual asset. So then what's new? This has been there for a long time. We've been talking BIM for decades now in our sector. So if there is a BIM model and there is a building, what's new? What is a digital twin then? Very clearly, if you think about it, a digital twin simply has a bidirectional connection between the physical and the virtual. Bidirectional, that is, the virtual is connected to the physical, and the physical is connected to the virtual or digital. The loop that is formed, this bidirectional loop, is essentially focused on enhancing performance and outcomes of your physical asset. It does so by deriving real-time information from the physical asset and pushing it back into your digital asset. So all the data about entities and processes in the physical asset is updated into the digital model or the virtual model. And there are two aspects of that definition, which are fidelity and frequency of that update. But the key is that you are able to then drive insights, make decisions using the digital model or the virtual representation, and then take action through a set of physical actuators in the physical twin. I gave you an example. If the garage door was left open, you will get a sensor to send you a signal that you left the garage door open in your physical asset. Now you can make a decision and push a button on your app or the interface or the dashboard and make a physical action take place in the physical asset. So that technically, that bidirectional loop is crucial. But now, do we stick to that definition in the real world? Perhaps not, because it's still an emerging field. So if you were able to take laser scans and photos of your construction site and put them onto the digital or a BIM model, partially you have done what a digital twin will do, but perhaps the feedback loop, the action part may be missing. But as the field emerges, we still are making those sort of decisions as we move forward. So at the heart of a digital twin, this is what the definition is of a digital twin. But there are technical definitions available. There is an ISO standard 23247, which applies to manufacturing, and it states a digital twin is a fit for purpose digital representation of an observable manufacturing element with synchronization between the element and its digital representation. What we follow, what RICS follows and our member firms follow is a definition by the Digital Twin Consortium. DTC is a US-based not-for-profit entity that has been brought together by the likes of Microsoft, Autodesk, and other major industry players. It's sector agnostic, so it applies to the energy sector, perhaps pharma and others, but it also has AECO working group, and I'm a co-chair of that working group, where it is defined, a digital twin is defined as a virtual representation of real-world entities and processes synchronized at a specific frequency and fidelity. So that's sort of the technical definition. There are other definitions. We work closely with the Center for Digital Built Britain at the University of Cambridge, and they define digital twin as a realistic representation of physical assets. For example, a digital representation of an airplane that can be used to monitor, predict performance, feeding out insights and interventions. So what you would have noticed by the examples and by the definitions is that right now, the industry, the construction sector, or broadly the built environment sector uses digital twins mostly during the use phase of an asset. So most examples are, can I turn on and off a switch in a conference room when it's not occupied? Can I measure the temperature, humidity, and other factors in a space? Can I figure out maintenance and operation decisions on assets? So very quickly, you will notice that most of the literature available right now focuses on the operation, maintenance, and end-of-life aspects of a digital twin. But what we have done at RICS is that we try to now connect it back to the design and construction phase, because we believe that digital twins should be used as early in the life cycle as possible. So we took all those definitions of a digital twin and brought them into the context of design and construction. So I'm going to try and utilize that to explain a little bit more, and hopefully not bore you with over-defining. But this is how we see it. Remember, the key terms from the definition were virtual representation of real-world processes and entities. So notice that a digital twin really is a digital replica and a physical entity together, synchronized, connected bidirectionally in this loop. The digital replica is essentially a virtual representation. You may have a BIM model or you may not. You don't need a BIM model as a virtual representation. So a virtual representation could consist of models, drawings, images, laser scans, videos, other types of files, lots of data in Excel spreadsheets and other spreadsheets. So that's the virtual representation as we see it. The real world entities are both entities and processes actually are things like equipment, a product, a worker, a site, a system or a subcomponent, spaces and occupants, assets or network or systems of assets. So today, digital twins, people are talking about connecting digital twins or integrating digital twins with each other. So you may have a digital twin of a block on a campus, another digital twin of another block on campus. You can connect them to create a digital twin of the system of assets or your network of assets. At the same time, the real world entities also need to have real world processes. So both design, construction, asset management processes are also part of the real world, which needs to be virtually represented. Now, very quickly, you will realize that most of this comes in the design and construction phase, either for a new build or for an existing asset where you undertake maybe refurbishment, rehab, renewal of the asset. So therefore, it is very crucial that we start thinking, planning, and producing, developing digital twins in early stages of the project itself. So you have a virtual representation, a real world entities and processes that come together to create a digital twin. The only other aspect that's remaining is synchronization. Imagine creating a BIM model at one stage of the project, then doing construction, turning it over the asset to the operator, and the operator makes changes. If you are not going to update your BIM model through those steps, then very quickly the digital twin concept falls apart. Therefore, we need to keep these synchronized, and the synchronization could be unidirectional, bidirectional, or by human in loop, meaning somebody physically goes, gathers updated as-built information and brings it back and updates the virtual representation. So therefore, there are two aspects to this synchronization: fidelity, which talks about accuracy and precision, and then frequency, which is how quickly and how often do you update or synchronize your digital and virtual with the physical. So that's sort of a very detailed, perhaps Mickey Mouse definition, description of a digital twin as applied to the construction sector. So you may see, again, I previously mentioned, what if there is only one-way connection between the digital model and the physical asset? Technically, that should be called a digital shadow because you do not have the loop or bidirectional connection. But today, as we are moving forward, there are instances where this portion that is a digital shadow could be considered a digital twin as well. Technically, though, it needs to have this bidirectional connection. So as we start discussing digital twins, you will notice that designers, constructors have a significant role to play, because a digital twin at the end of the day is all about data and information. And we as constructors produce lots of data and information about the physical asset during the design and construction phases. Therefore, keeping that data and information embedded into the virtual representation and creating a process through which turnover, handover takes place in a very systematic fashion is crucial. One of the concepts then that supports this way of thinking is called a golden thread. So a golden thread is a key information passed across to future building owners to underpin more effective safety management throughout the building life cycle. This is a definition which you can pick up from some of the UK legislation post the Grenfell Tower tragedy when the fires engulfed those towers. And you will basically see that the idea of a golden thread connects very well with the idea of a digital twin. But more importantly now, folks are talking about what's called a digital thread. A digital thread can be viewed as containing all the information necessary to generate and provide updates to a digital twin. What is a digital thread? A digital thread is essentially a digital representation of information which connects all the life cycle steps. Because if you generate some information at the concept or design stage, do lots of synthesis and analysis on that data, do make decisions, but if you don't connect all this information and carry it forward into the construction, manufacturing, operation, post-life, those phases, then the idea of digital twin doesn't really work. So this actually comes from the manufacturing sector. There's a paper that I've used and copied this representation of the idea of a digital thread. So digital thread is fundamentally important if we are going to go into the digital twin journey. So that's sort of the basics of a digital twin. Let me now start taking this discussion over to a little bit more of the design to turnover steps so that it becomes more relevant to your class and to your program. So as you all know, or may very soon come to know, that we've been on the building information modeling or BIM journey for a long time. The industry perhaps is now looking back at that journey and saying, hey, we would have been better served if we really didn't use the term BIM, because it has numerous challenges and issues. As soon as you say building information modeling, people get different ideas. Mostly they think a building information model is a 3D model, whereas a building information model should really be an information management tool. So BIM should be seen as a design and a visualization, design collaboration and visualization tool, which is how people think about it right now, because of which many downstream processes and experts are still not engaged after perhaps 10 years of using BIM. Cost consultants, FM and OM folks, product manufacturers, clients still do not fully utilize the potential of BIM because the focus is on 3D modeling, design collaboration, and visualization, not really on information management. Digital twins, in a way, shifts that and puts the focus and context on IM rather than BIM. So as we start thinking about this idea of digital twins, we have parallel, sometimes, efforts going on. You create a BIM model to help the design, clash detection, collaboration, visualization, perhaps 4D planning, 5D, 6D, and all those aspects being carried out on the digital front. Then you bring it to a construction site where lots of things happen. Maybe prefab happens, assembly happens, and so many things happen. So many new initiatives have come across. And you will see people using drones, laser scans, videos, photographs to get a better understanding of what's happening in the design and construction stage. Here is an example from PCL Construction. They've started using IoT layer to really get a dashboard which can help them study water leaks and flooding during construction. They can even see the concrete strength and maturity on a dashboard, air quality and dust and noise perhaps on a site. They can find out the location, utilization of tools and materials. They can do other kinds of savings and measure temperature, humidity, see the location of workers, check their maybe health and productivity and safety and other aspects using a layer of IoT. So here you have lots of efforts going into the design and construction through BIM models and other digital tools and models, and another set of activities for progress monitoring, for project control, and other aspects using latest technologies happening in parallel. Now, what if we were to combine these and start producing a digital twin? So obviously in construction, and when you talk about a digital twin, initially you're not going to have anything on site. Nothing physical exists yet, but we continue with the digital or virtual pieces. And then when construction is being stood up, you combine the two. And as construction closes and you move towards handover or turnover of the asset to the operator and the owner, you combine all this data, all this information into a digital twin and hand over the asset and the virtual representation bidirectionally connected in a very systematic fashion. So therefore, design and construction is crucial and plays an important role. And we tried to bring all of this together in a book that I wrote with a couple of my colleagues, Javier Irizarry from Georgia Tech and Mike Riley from Liverpool John Moores University in 2020, where we basically are saying that there's a lot of progress being made today in the construction sector, but sometimes it's not unified and glued up together. You have on the physical layer, on the construction side, folks have worker sensors now or wearable devices where you can see what's happening with your workers. You have robotics automation, you have IoT, 3D printing, lots of other prefab and other physical technologies helping with the production process. You have a digital layer where you have maybe a cloud-based common data environment or a repository for all your information. You're doing BIM, but you're not gluing all this together if you don't think in terms of a digital twin. Once you start thinking in terms of a digital twin, you can then deploy several digital tools or dashboards that can then help drive construction forward. And this is what the Construction 4.0 framework, the topic of our book is, and the connectivity of digital twins to that Construction 4.0 framework. So at the end of the day, the vision is that we will BIM it, we'll twin it, we'll build it, and we'll operate it. So you have projects that turn into assets. We will start BIMing, twinning during design and construction and carry it through into our assets where we operate, maintain, renew, and even do end of life, recycling, and other stuff, repurposing using digital twins. Now, that then will help our sector address very important outcomes that the society is expecting from us today. Environmental outcomes, everywhere today you will see we talk about decarbonization of the construction sector. In fact, I moderated a webinar yesterday for RICS where we talked with experts from Skanska, CBRE, and GLEADS, discussing how decarbonization is important. We'll also talk about social outcomes from our projects and assets now, and obviously we've always talked about economic outcomes. So with the help of this vision of BIMing, twinning, building, operating, we should be able to get that vision accomplished. But what's crucial is data sharing and collaboration. So as an industry expert, to accomplish those outcomes or broader impacts, we use all the tools, technologies, paradigms available to us. But at the end of the day, if we don't share data and collaborate, none of this is possible. So that's sort of how we can bring it into the construction sector. I'm going to quickly share with you a global survey that we ran to understand the current state of digital twins. So when we did a survey last year, late last year, this is what we got back, and it's not surprising. very few of those who surveyed are actually using some shape form of digital twins. About 21% are currently using digital twins. About 18% have taken the first steps to implementation, but a large number, a majority of our respondents, who are both members and non-members, say that either they are not considering, they have not heard of digital twins, or they're not using it. So that's the current state. In some ways, it reflects how building information modeling was used in our sector also. If you look back at that journey, the initial adoption was low. And what are digital twins being used for in the design and construction stage? The top three uses, as you can see, are facilitating data sharing to deliver performance efficiencies for all stakeholders, gathering real-time site data for decision-making and collaboration, and then progress monitoring and project controls is the next important use of digital twin during the design and construction stages. We then ask the same question, but in the operation stage or the in-use phase of the asset. So now the project is complete, the asset is running. What are the top three uses? The topmost use is obviously gathering real-time asset operation and maintenance data, making better operation, maintenance, and renewal decisions, and improving asset performance and owners' bottom line were the top three uses of digital twins during that stage. We then asked, what are some of the deliverables that owners, project proponents are asking to be produced from digital twins? As-built BIM models is the topmost requirement. So being able to take all that building information model, all the data and information gathered, and compile it, quality check it, and produce it into a format that then can be converted into a digital twin is the topmost expectation. So if you look at several airport projects right now in the US where digital twins are being adopted, the focus is to assure that all the design, engineering, construction data and information that was generated during construction is packaged into a BIM model that is ready to be used as a digital twin. The second deliverable is dashboards showing connected real-time asset data, occupancy data, occupant satisfaction data, productivity data, all that into a dashboard. And then thirdly, digital assets for various work processes. When we asked our respondents, where do you think digital twins play the most role? The current perception is digital twins are only useful in operating an asset. They may not be that useful in the design and construction stage, but surprisingly, 64% of the respondents told us that we have the use of digital twins across all life cycle phases. In fact, respondents saying that digital twins should be used as early in the life cycle as possible. When we talk to respondents about the blockers or barriers to using BIM, to using digital twins, obviously the first response was high costs, including direct and hidden costs, no real demand or financial support from clients, perceived complexity due to lack of information and training. And actually, if you think about it, we thought shortage of skilled professionals would be a challenge, but it looks like digital natives, like folks in this class, perhaps have all the digital tools needed to deliver digital twins for our sector. So therefore, it's not really ranked very high in terms of the score. And the score here is what we call the RII, the Relative Importance Index, that was calculated based on the survey that we did. So that's sort of where the main barriers to implementation are. And those were divided again, design and construction stage, and during the use phase of the asset. The only change here is that in the use phase, there's a lack of standards, because imagine having thousands of IoT devices, sensors, and so on in your asset, and data streaming in, which probably does in building management systems anyways, but not having a standard which takes that raw data, uses perhaps AI or machine learning to provide you with insights and based on which you can make decisions. There is a lack of standards there. So we looked at some other surveys also. This is something done as a national BIM survey in the UK every year. And it seems BIM is becoming business as usual, which is critical to building the foundations for digital twins. When that question was asked, about 45% of the respondents said that that is the case, that BIM is important, even though you don't need a building information model to build a digital twin. But those who have traveled that journey, have mature BIM processes, obviously can do better on their digital twin journey as well. So a good number responded that it's needed, it's useful, or it's critical. So that's sort of where the current state lies. I'm going to give you a little bit of a flavor, not too much, of what is really happening when we talk about digital twins. So this is a screen grab from an article by Siemens, where they talk about a digital twin for a building. As I said previously, there may be a stage where there's nothing on the ground yet, but you start preparing its digital or virtual representation in the form of models and start embedding those sensors and other networks into the system. But as the construction progresses, you can continue to improve and develop a high fidelity virtual representation. Once the physical asset is turned over or handed over, you combine these two to truly give a digital twin over to the asset operator that then continues to use for making asset decisions. So if you think about it, step back, a digital twin from a schematic point of view is really consisting of, again, the physical asset and the virtual representation. The virtual representation is something that is developed during design and construction and post-construction through maybe laser scans and reality capture of existing assets. So you have some static data, which is done through design and construction, but that needs to be stored in a repository. Currently, we use the common data environment as a repository. And that needs to stay synchronized, so any design construction changes need to be always brought back into the virtual representation. But then when the physical asset is being stood up during construction and is being used during the operation stage, you will have lots of other things happening. You'll have videos, point clouds, images, IoT, sensors, RFID tags, your asset management systems that'll bring edge data, it's called, or edge computing, dynamic data into the mix, which again gets stored in this common data environment, which basically needs to be then put into a dashboard where you can use AI, machine learning, simulation, visualization, and have a human in the loop who can help make decisions and have physical interventions through an actuation layer. So basically, as the project progresses, you will get loads and loads of data. So as designed and planned data, then as built data, and then performance data, all of that needs to be collated, collected, so that you can develop a digital twin, use it, keep it updated, because if you don't update it very soon, that's going to become redundant. Lots of technologies can be used, and I've discussed these before also with you. So you may run across various scenarios. You have an existing asset. Do you need a digital twin? Perhaps all you need to do is a reality capture, put sensors, create a dashboard. You may have a new asset, but the owner doesn't want a digital twin. Maybe all you need to do is prepare the virtual representation, do a traditional handover or turnover, and let the operation stage take care of a digital twin. You may have a situation where a completely new asset is being built and digital twin is required during design, construction, handover, and use stages. You can again deploy then full-scale digital twin implementation. So you can use digital twins for many things. You can streamline supply chain, you can do energy calculations, you can run what-if simulations, you can make investment and financial decisions using a digital twin, you can reduce the life cycle costs, you can enhance schedule and cost uncertainty. So in abstract, there are many, many benefits of digital twins during design and construction, but how well we really capture these depends on how well we take on the digital twin journey. So during these processes, ideally, we could use digital twins to increase productivity and operational efficiency of design, construction, and handover processes, increase collaboration, improve worker safety, health, and well-being, reduce environmental impacts, reduce life cycle costs and carbon emissions, and improve asset performance. Before building a digital twin, you may use this process. Do you really need a digital twin for your project? A go, no-go decision that truly should be based on use cases. If you don't have enough use cases, probably not a good idea to go down this path. And if the answer is go, then you develop a business case, come up with a procurement strategy, an implementation strategy, very similar to what our industry is now used to doing building information models. There are guidelines, consensus docs, and standard forms of agreement available to deploy, procure, implement BIM. Something similar can be used for digital twins as well. So what are the benefits and quick summary? You can have digital twins at various levels of abstraction. Descriptive digital twins that only help you collect and visualize data. You can have informative digital twins that take that data and generate insights. You can have predictive digital twins that take that data and predict the future state. So you can run what-if simulations. You have comprehensive digital twins that combine all these levels and help you achieve better outcomes. I don't know when this would happen, but you could have autonomous connected digital twins that run on their own. Perhaps not happening soon, at least in our sector. Today, digital twins are being talked about in terms of the human body, digital twins of a smart factory, digital twin of the entire organization. So there are numerous benefits. I won't bore you with these, but broadly, they all should help us improve design, construction, and delivery of new assets. They help reduce construction and operating costs, productivity and collaboration, safety, asset performance, and sustainability. Want to know more? You can download some of our key publications. The first one from which most of the information for this presentation I drew, written by my colleagues and myself, called Digital Twins from Design to Handover of Constructed Assets. You can scan that QR code, takes you to that link and download. We recently also released another research report called Digitalization in Construction. You can scan that QR code and download that free Digitalization in Construction report. Obviously, I encourage you to buy my book. You can go to Amazon, click on that QR code and buy the Construction 4.0 book as well, which talks much broadly about all these aspects of Construction 4.0. With that, I would close, say thank you, and perhaps, hopefully there are some questions or further discussion. I'm going to stop sharing, but here's my email. If anyone needs to reach out to me, I'm quite active on social media, mostly LinkedIn and Twitter. I'm still learning TikTok, but perhaps very soon. Thank you.
Thank you very much, Dr. Sawhney, this timely presentation. We really, really enjoyed your talk. So the platform is open for questions now. I have several questions. Let's start with Dr. Mirando. By the way, again, I want to thank Dr. Mirando for making his class available for this presentation.
So I'm curious.
Yes, you can come over here if you want.
Thank you so much. I'm curious. So we currently have a BIM course that's required for our students. What else do you think we can do to prepare them to operate within these kind of models in the future? Like, do we need to integrate it in the BIM course? Is there some additional workshops, or do you have any recommendations for undergraduates who, can better operate within these twins? Thank you.
Sure. No, I think that's an excellent question. So really, a few things that I'd like to say. I think in our sector, it's written up somewhere by an industry professional in an article. We have the habit of taking a one at a time approach. When we talk BIM, we talk BIM. When we talk lean, we talk lean. When we talk green, we talk green. In a BIM course, you can actually integrate all of that together. So obviously deep dive into BIM, but also highlight a couple of things. One, the importance of data and information. It's not about BIM authoring. While that's important, but the ultimate goal is to get good quality data and information. So information management is crucial, and that leads to a digital twin. And then also share the connectivity using either a construction 4.0 kind of a framework or industry 4.0 framework. In fact, now industry 5.0 framework, to show the connectivity between all of this. If BIM is central, what can it help us do? How do you connect the drone images into a BIM model? How do you use, perhaps not deep dive, perhaps not hands-on, but at least an exposure to the bigger picture of this aspect of construction technology probably would be useful, in my view, for students.
And the extension of this question is, to me, obviously, since the introduction of sustainability concepts and advancements in technology, starting from mid-2000s, we have a lot of, we have a big, attribution to pre-construction phase, where we have major roles in pre-construction. I think it's becoming more and more important. Well, how do you think the profile of construction professionals will change with all these developments? Because we have more emphasis now on the life cycle, starting from the design phase and post-construction and all the useful life. All the decisions we make during the design phase impact the useful life, the overall life cycle. How do you think all this, how do you think this trend is actually affecting the profile, expected profile of future construction professionals? And this is the extension, this question is the extension of Dr. Miranda's question. How should we prepare our undergraduate students for the industry? On the other hand, industry has its own unique profile. It's relatively slow in adapting the newer approaches and technologies. And obviously, this was very clear with the results of the survey you showed us.
Absolutely. I think that's a very, very relevant and important question, something that we are very passionate about. So as I was mentioning in yesterday's discussion, just taking US as an example, the recent Inflation Reduction Act has $250 million worth of funding for decarbonization of various sectors, including the construction sector. So our members are mostly cost managers or cost planners or cost management consultants. If you are a cost estimator, for example, you can play a significant role in the decarbonization. At the end of the day, if you think about the complexity of carbon emissions, but at the end of the day, it's really multiplying all the products, materials, and their quantities with carbon emission intensity per unit. So it's very similar to cost estimate. So in our view, cost estimators are going to play a significant role, and therefore our members are going to play a significant role in decarbonization also. There are embodied carbon and there is operational carbon in a built asset. We are all good at looking at operational carbon because primarily operational carbon is operational energy. And as we decarbonize the energy grid, the carbon intensity there can be reduced. But the embodied carbon, which is carbon that goes into steel, concrete, plastics, doors, windows, carpet, paint, is already spent, right? It's already emitted. We got to find ways to use better materials, calculate those materials better, be able to use options and alternatives and compare them. And that's where construction management students and the construction management profession has the expertise. Doing value engineering from a cost perspective can be expanded to do value engineering from carbon point of view also. So as we progress and more laws are coming into place. So if you go to New York, already there is regulation. It's called NYC Local Law 97. I think by 2023, 2024, buildings above a certain size, if they emit more carbon, they will be penalized. So it has direct monetary implications on building owners, which we know in our industry then drives action. So if we have construction management students who not only know about cost estimating, but also carbon accounting, I think that'll be a great way to move forward. Sorry for the longish answer, but I think that's where all of this is headed. I'm happy to share. I'll try to find out if we can get the recording from yesterday's webinar where we had somebody from Building Transparency and others speak about this very issue.
That is great. Thank you so much. Other questions? Yes, I'll take another question here. You can come over here. Yes.
Good morning, Dr. Sawhney. Thank you again for everything. I have two questions for you. I'll leave them into one question. My name is Aiden Swable. With this new technology that's leading in front of us, do you fear that there's a security threat with this? And if you do fear that there is a security threat with this, do you fear that we're moving too fast? Thank you.
Boy, I think you really highlighted what I missed talking about. That's a huge, cybersecurity is a huge challenge. Just imagine producing, like for my house, the website where you can see every camera turn on, any light switch or fan or window or any such thing, poses a huge security challenge. But then there is already effort taking place. There's a new ISO standard for cybersecurity of BIM models, which can be applied to digital twin also. Are we moving too fast? Probably not. I wouldn't say just because there is a threat from cybersecurity that we are either moving too slow, too fast. All we need to do is keep that in focus, in mind, because if we don't, we can end up in a very bad situation. So absolutely an important topic. It's being addressed. For example, NIBS, the National Institute of Building Sciences, had a seminar recently on security, cybersecurity of BIM models. Something people are studying, something that's getting the right attention, but extremely important topic.
Thank you so much. Other questions? I think this is it. Again, thank you for making time and being part of this talk series at Kent State University, Dr. Sawhney. I hope we will interact and we'll see you another time in person here at Kent State campus.
Anytime. If you, I would start driving when you give me an invitation.
Thank you.
Thank you.
Have a great day.
Thank you, everyone. Bye.